Hello guys. Last time we managed to get the day 5, part 1 and part 2 completed. And in this video, let's continue with the day 6. So let's jump to the puzzle. So yes, not return to day 5, but if we go to the... So yes, day 6, Card Caliban. The historians use their fancy device again, this time to whisk you all away to the North Pole prototype suite manufacturing lab. In the year 1518. It turns out that having direct access to the history is very convenient for a group of historians. You still have to be careful of time paradoxes, and so it will be important to avoid any from 1518 while the historians search for the chief. Unfortunately, a single card is patrolling this part of the lab. Maybe you can work out where the card will go ahead of time so that the historians can search safely. You start by making a map, your puzzle input of the situation. For example, so it's dots, hashtags, and carrot. The map shows the current position of the card with carrot to indicate the card is currently facing up from the perspective of the map. Okay. Any obstructions, crates, desks, alchemical creatures, etc. are shown as hashtags. Lab cards in 1518 follow the very strict patrol protocol, which involves repeatedly following these steps. If there is something directly in front of you, turn right 90 degrees. Otherwise, take a step forward. Following the above protocol, the card moves up several times until she reaches an obstacle. In this case, a pile of failed suite prototypes. Okay, we can see. Because there is now an obstacle in front of the card, she turns right before continuing straight in her new facing direction. Yes. Reaching another obstacle, a spool of several very long polymers. She turns right again and continues downward. Okay, yes. This process continues a while, but the quad eventually leaves the mapped area, after walking past a tank of universal solvent. By predicting the card's route, you can determine which specific position in the lab will be in the patrol path, including the card's starting position. The positions visited by the card before leaving the area are marked with X. Okay. In this example, the card will visit 41 distinct positions on your map. Predict the path of the card. How many distinct positions will the card visit before leaving the mapped area? Okay. This kind of reminds me of the Xmas puzzle. So maybe we could let's actually add the text separator day 6 part 1, and let's start by getting our puzzle input. How does it look? Okay. And if we try just out of curiosity find the card, if we search for this character, we can find it. So the initial direction is up. Okay. Cool. Let's start by setting the map up. Okay, and then let's do the usual split. So now we should have a list of strings as a map. You could check that out. Yes, good. Okay, next one, we want to locate the card initial position. So we want to have X coordinate and then Y, which are basically which row and which column or character in the strings. And then we need the direction. For this, we could just use maybe integer values, which would be, we could use, for example, that 1 is up, 2 is right, 3 is down, and then 4 is left. Just to kind of keep the syntax a bit smaller, that we need to type. And to locate the card, of course, we need to have the card. So we can get it here. And card is this. So basically, we want to look for row in map. If card in row, we know that wait a moment. We actually need to enumerate this map. The reason is that we need to also know in which row the card was found on. So if the card is in the row, we can get the card position by getting the index. So I was thinking that if we think the coordinates so that the top left corner is x0 and y0, and then kind of we go to the positive direction when we go down towards the bottom right corner. And in this case, we can basically say that y is index, and then x is row dot index, and then substring is basically the card. And now if we print x and y, we will get 72 and 92. So if we would like to check what character is in that location, we could just get the map row 74, which is this, and then sorry, not 74, 92, yes. And we can see that the card is there, and if we now get the 74th character from that string, we should have the card. Yes, that's good. And next thing, so we have now the starting position of the card known. So what we could then do is implement this move card function. So basically, since this kind of feels already a bit complex, this part 1, I was initially thinking that basically a while through loop, and we could kind of do the logic there, but if we already split it up a bit, I would think that we are better suited for the part 2, whatever it is. So basically we want to move the card, and we want to give it at least the x, y, and then the direction that we have currently. And basically what we need to do is that those are the current position of the card and the direction. So basically we want to check first the direction. So if direction direction is up, we would just write pass for now, and then elif direction is 2, and now we can just copy paste that one. So we need to handle every direction. And what we want to check here, so direction up means that we are moving in the y-axis. So here we want to check that for because we are moving in the rows, we want to get the for row in map. And we could already limit out the rows. So we want to get everything that happened before the y and then loop them through. And in addition to actually just getting these, because now the rows are so that they are kind of starting from the furthest one from the card's point of view, and then they're coming down. So we want to actually reverse this array or list. So now we are kind of starting from the card's point of view, go one by one further and further. And what we want to check is that if row and then this x coordinate, because that doesn't change, it is constant in this case every time. If it's hashtag, we know that now we have hit something. So we want to update new x. So basically, from this function, we want to return updated x, new y, the new direction, and so new y, or sorry, new x is still x, that doesn't change, but then the new y would be, actually we need to enumerate this as well. Lot of enumerations needed. We want to set the new y to be basically the current y minus the index, y minus index. And actually in this case, we need to subtract 1 from the index, because we are already in the row where the obstacle is, so we need to kind of back up 1. And I think this should be all. Of course, we need to update the direction, which would be 2 in this case, because the current direction was 1, so we will rotate 90 degrees. Then if we go to the second part, we can technically copy this, of course. Yes. And what is actually changing here is that since we are going right, the y is constant. So we basically know that which row we need to go through. So instead of doing all of this. We don't need to reverse this one at all, but we want to enumerate it still. And actually, sorry. We want to get the, or can we actually do it like this? So we have the one specific row. If we enumerate that one, actually, yes, we can do it like that. So what we want to do is actually add second, what is this called? So basically we have the row, but in the row we want to limit the, or also like slice already the more interesting characters into use. So instead of row, we are looping characters. And in that case, if character is hashtag, we already know that we have hit something, so we need to update x, so it will be, in this case, actually x would be plus index -1. And then y is staying the same. Direction will be updated to 3. Okay. Then 3, we are going down. So actually for that we can use this same code. So we, instead of filtering out the rows after our current y position, we will get the rows after our current y position. And instead of minus, we will do plus here, and then update the direction to be 4. Yes. And then for the last, since it's going left, it is basically mirror operation from the going right. So y is still the same, but x we want to change so that the x, or we will now or we are now interested in the characters before our card's current position, and these ones, these ones we want to actually also reverse, so that we are going from the point of view of the card. And this actually is now also wrong. We don't want to reverse these, because it's already in the correct order. So now we should be good. And if we run it, no errors, that's positive. And did we have, so basically now we would like to create the actual kind of logic, or kind of the core function or loop that handles everything. So for that we could do for in range 3, let's say, just kind of limit the executions that we will do. And instead of actually using x and y directly, we want to maybe use current x, which is the x, of course, current y, which is y, and then direction, which is, oh sorry, current direction, which is direction. Oh, different space. And in the loop itself, we want to call this card move. And of course, we want to use these. Or maybe it would be better to use something like move card actually. And what it returns is the new x, new y, and the new direction. So we can just catch those. And then let's see what. So basically, we're interested how many distinct positions the card will visit before leaving the mapped area. Let's first just to make sure that we have something working, we could just run this. Yes, it prints the same value, and that is because we need to then, of course, update the values. Current y, new y, and then current direction with new direction. So now we should be able to get different values. Yes, wonderful. So what we need to achieve this is that we at least need some way to store the visited positions. So I was thinking that if we store them, what would be the best, or which way would be the best? Basically, map could be one, as it will kind of always, because it's distinct positions. We need to just keep the unique values in. But maybe dictionary would be better for us in this case. Maybe we can see a bit better how the card moves their visited positions, and like that. And with visited positions, we can follow up or keep up the positions where the card visited. And since now we don't have exact info about which positions the card visited, we could do so that we kind of calculate them in. So basically, if we get the min x, so basically we can calculate the positions by checking the path that the card moved. So I was thinking that if we get min x, which would be current x, and then new x, and then if we get the max x as well, so then we know that what is the movement in x-axis, and then same for y. Yes. And for these, we can just do basically for I1 in range of, it doesn't really matter which one we use first, but basically min x, max x. And now, since we had the issue with the range function in the second day puzzle, we know that, or we remember to add 1 to include also the max value. and then for I2 in range, min y, max y plus 1. And then we just do visited positions. And add the item in. So what we would add is basically string index 1 or I1. Then we want to have is stringified so that it won't just sum them up, because that would be problematic. And you can just set it to be 1. And if we check this, okay, it will loop them through visit positions, and then we have the entry. Actually, we need to modify this, so I think that we need to add a separator here. And that's because if we have the I1 to, let's say, I1 is 7, and then the I2 is 11. So the entry with the previous logic would have been 711, and then or the key would be 711 and the value would be 1. But then, and that would work completely. But then if we have another entry with 71 and then 1, it would be completely different position, but the key would still overlap. So let's have that separator there. And if we now run this, kind of, maybe we could print length of visited positions.keys. Okay, so we have quite many positions there that we have visited. Okay, we could do small test. Since we have this example here, we could do, let's say map2 is like this, and then split this in the same way as we did for the other map. We used the map here, so we can just do map2. And then here we don't have any reference to the map. Okay, so actually we could turn this to be while true, so it will run until it won't. And I guess this, if nothing, since these are not set, they should be null. So I'm thinking that could we just check that if new x is none, then break. Let's see. It says string index out of range. Okay, so are we doing some? Yes, that should be minus. Because we are going left, so we need to take that in account. And this is 5. Let's print the... Now I actually know. We haven't run this. So we need to update this one. Yes, okay, now it could work. Cannot access local variable new x, where is it associated with the value? Okay. Actually, this is wrong also. Yeah, okay. I don't know. Yeah, because we copied it from here. Okay. Let's run it now. But it says that that. So 4, 2, and 2. I'm wondering a bit that why we okay. So let's actually print them here. Print them here. And then we can delete this one. And we can do maybe like this. So 4, 6, and 1. Okay, that looks good. So what we will do then, we will go through the rows. Maybe we can print the row. And it will update it to the 4 and 2. Actually, that seems to be wrong. I think actually we might be able to do it like this. Let's see. 4 and 1. Okay, we got further. And then so basically we are going here, and then we are going in the same row to the 8th index. So 4th, 5th, 6th, 7th, 8th. And then we are going to the 6th. So 2, 3, 4th, 5th, 6th. Okay. Then we are going to the direction 4, which is then going to the left, and there is actually same issue. So it should stop to index 2, but it's 3, so we need to take that out as well. And then we managed to get further. So it will go 2 and 6. And then the direction is up. It will go from 2 and 6, it will go to 2 and 5, 4. Yes, and then 6 to 4, 3, 4, 5, 6, yes. And then it will go down to 6 and 8. yes. And then it will go 1 and 8, yes. And then it will go 1 and 7, yes. And then it will go 7 and 7, yes. And then it goes actually out of bound. Okay. So unbound local error. Okay. So basically, do we then know that? So if we have an except, can we use this unbound local error? Actually, be more specific. SE. And okay, so this didn't work, we know already. So what we need to do here is break at least. And we need to actually, I think, do the same. We could move this to here, or copy. Yes. And now if we run it, it goes through. But in this case, since we don't have new values set, so new is a bit unknown, so we need to calculate this new x and new y values. And so if we know that current direction is 1, so we are going up, we can say that the smallest value we can have is new y of 0, and then elif current direction 2, so we are going right. The new x can be maximum of length map 1, or the first array of the map. This is we can do this because we know that the map is kind of every row is same length, so you can just trust that. But if, of course, we could get the current row, but this should work as well as that. And then another case, current direction is 3. So we are going down. New y is basically length of the map, so how many rows there are. And then elif current direction 4, which is then that we are going left, is new x, is basically 0. So if we run this, we get 162. Yeah, we need to set new x to be actually the same current x that we have, because we need the both values. And then new y is current y. Yeah. And why it is still going south. So let's print this here. And let's actually remove this and this here. And then run it. So we have 39 and then it jumps to 162. So which is the current direction? It should be down. Yes, down. And the current okay, now I know. Okay. Okay. Yes, of course. We started to reference the map, but we should use the map too. Yes. So now if we run it, it says 42. Which is actually correct since these we need to the maximum value is not the length but instead just -1. Yes, and that aligns well with the example. So now we can try to solve the actual puzzle input that we had. So let's run map and then calculate this. 7492 looks correct. And then we can run this. And I think we should be able to run this as well. We don't have any reference to the map2 anymore. So let's run. Okay, 132. I'm a bit suspecting this one. But I guess we could try. So 132. Too low. Okay. So what we have in the visited positions then? So this is good. And then we want to just update that new direction. Yeah, it is. Okay, so let's print these once again. So it stops very fast. So 72, 92, those were the starting position, yes. And then it moves to 74, 16. Yeah, I think that sounds... if we check that position from the map, then first get the 16 row 16 and then the 74 That does not look good. But this was our starting point, yes. Aha, okay. So if it's 74 and then sorry, it should, so if the 16, so it should be 15. Okay, so that's correct. So then it starts to move from that 16 to right. And this won't never. Do we have some logical, or do I have some logical error here? Two. Direction 2, yes. Then let's check this one out, that it actually works. So we have as an y we have 15 and then as an x we have 74. Then if we, or maybe we could actually first just check what we get from this. Let's print this out. Oh, 16, sorry. Interesting. So how does that, now I'm wondering, am I having some issue with the, oops. Basically, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now I'm like thinking that, do I do this wrong? And what's up with this? What's up? I'm actually wondering, do I need to, is it, because these are for loops. It's just I need to break them. Okay. Yeah, because they continue to run until the end and okay. Okay. Now it looks something that I could imagine that from this we could get. So let's wait a moment. Which one is the last one? It's this one. Okay. Yes. Wonderful. Yeah, I think the video has gotten a bit long side already. So let's pause it here. It was interesting to see how the difficulty level actually rose from the 5th day to this 6th day. So that's interesting to see also how it evolves during the Advent of Code challenge. But thank you for watching the video and see you guys next time. See ya.